This is Susan Purdy for discussion 3, pH titrations of strong acids and strong bases. This is my 4th attempt at trying to record a video, so I hope you will just bear with me on this one. First of all, I wanted to write out the equation, the chemical equation, make sure it was balanced, and since it's 1 to 1 to 1 to 1, the ratios are very simple, straightforward. I was given 2 assigned volumes to calculate for. First was 24.32 mils, and the second is 57.36 mils. So we'll look at the first one first. I started with 50 mils and converted that to liters, so I have 0.050 liters. And I wanted to write down the molarity of the compounds I'm working with, sodium hydroxide and hydrochloric acid, just to refer back to them as I do my calculations. So in order to find the moles of hydrochloric acid, I start with liters and multiply that by the molarity and get 0.01 moles of HCl that's been reacted away. In order to find my limiting reactant, I need to do the same thing for sodium hydroxide. And I did that here using the assigned value of, in liters, 0.02432 liters of sodium hydroxide multiplied by 0.250 molarity sodium hydroxide to get 0.00608 moles of NaOH. That's a smaller number comparatively, so that is my limiting reactant. I will then subtract it from the greater molarity to get 0.00392. That becomes my numerator when I'm finding concentration. So 0.00392 moles of HCl is left over, divided by the total volume, which was 0.02432 liters plus 0.0500 liters, and that gives me 0.07432. I'm sorry, these two numbers added is this. This number divided by this number gives us this, 0.05274, rounded to 3 sig figs is 0.0527 molarity of hydrochloric acid. In order to find the pH, I use the logarithm, negative log. We know this is acidic, so I can just jump right to the pH equation for that. So negative log times 0.0527 equals 1.278. Rounded to 3 sig figs, we get 1.28 for the total for the final pH. Now for the second equation, I had some trouble with this at first, I will just admit, because I forgot that it is now a basic solution, which we will see in a moment. So we'll get to that. So this second one, I was given 57.36 mils. I start with the same liters of hydrochloric acid. So when I multiply 0.05 times 0.2 molarity of hydrochloric acid, I get 0.01 moles. And then compare that to the sodium hydroxide of 0.05736, which was converted from mils to liters. Multiply that by the molarity of, the given molarity in the question of 0.25 moles NaOH, I get 0.01434 moles of sodium hydroxide. That makes hydrochloric acid my limiting reactant, and I then subtract it from sodium hydroxide to get 0.00434. That becomes my numerator, and I divide it by the total liters in order to find the concentration. And that gives me 0.04042 of sodium hydroxide. And again, because this is, now that we know that this is going to be a basic solution, I first have to find after I plug it into my logarithm. Negative log times 0.04042 equals 1.393. That's my POH, not my pH. Now I have to subtract this number from 14.00 and get 12.61 as my final pH. And you can see from all my scribbles and erases that I will never forget this again. Ta-da.